Harpy eagles are a magnificent raptor that live in Central and South America. However, their population has dwindled over the decades. This is the story of using cutting-edge technology, from UAVs to deep learning, in order to better understand the habitats they live in. There is only one known nesting pair of harpy eagles in the country of Belize. So let's use Google Earth to take a little bit closer look at the area that they're known to live in. As we zoom in here, we can start to get a view of the jungle. However, there's clouds and the resolution is terrible. There isn't much we can gain from looking at this information. So instead of using satellite imagery, we're going to use drones to get very high resolution imagery of this rainforest. Flying this drone, we were able to cover huge amounts of area and get resolution of 4 centimeters per pixel. Here you can see just one of the sites that we flew over in Belize. This is incredibly high resolution imagery, and the really cool thing is that each pixel has a GPS location. So theoretically, you could go out and find any pixel in the real world. Now that you can see when we zoom in, you can actually make out individual trees. So let's look around a little bit for some harpy eagles. Well, we can't find any. So we need to back up and take a look at the big picture. Instead of looking for harpy eagles directly, maybe we can look for these palm trees, which indicate to us the soil type. Or maybe we can look for these deciduous trees, because they're more likely to have harpy eagles' nests inside of them. The logical next step might be to actually try to locate each palm tree in this image. You can see from this that it is taking quite a long time to actually label each palm tree. Now, it would be much better if we could just do this for a few palm trees and have the computer learn what a palm tree looks like and automatically detect and localize where the palm trees are in the images. We're going to use something known as deep learning to automate the process of finding palm trees. We still need to create a small data set that it can use to learn what a palm tree looks like. However, once we do this, we can go through each of these tiles and automatically find most of the palm trees in them. And as you can see, there's a heck of a lot of tiles to get through. So let's see what those results look like. Each one of these little squares represents a palm tree that the deep learning algorithm found. And as you can see, there's a whole heck of a lot of palm trees out there. This is fantastic because now we have a process to automate the finding of palm trees. And from this, we can gain a lot of valuable information about the habitat that harpy eagles live in. Let's see how we did for the deciduous trees now. It appears that there's far fewer deciduous trees in this area than there are palm trees. However, looking at the results, it seems that the deep learning algorithm was able to find most of the deciduous trees in this area. So let's see what these results look like if we make them into a heat map. So here you can see the numerous amount of palm trees in red. You can overlay the deciduous trees in purple. This is where things get really interesting because you can see how these two types of trees grow in relationship to each other. Some of the highlights of this project are being able to detect palm trees with 98% accuracy and deciduous trees with 97% accuracy. This tool allows researchers to automatically detect individual species of trees with very high precision. This shows the power of combining both high-resolution images taken from a UAV along with deep learning as a valuable asset to ecologists who want to better understand ecosystems.